Hello everyone and welcome to Applied Engineering channel, and in this video we are going to discover how to use compressor maps in a single stage vapor compression cycle. So let's move on and dive into our simulation software, that is Cycle DHX. So what you have to do, you have to open Cycle DHX version 2 and then you have to go in the file. In the file you have to go to the open and you have to open the R410 AC file, which is the basic case file. You have to click on it and then click open. This will load our already file, which is R410A file, and you will see it has loaded the refrigerant. It has also loaded the single stage cycle, which does not include liquid line and suction line heat exchangers, and in the cycle specification it has updated all the temperature values. Now, what we have to do, we have to see here in the compressor, you can see it is showing the isentropic efficiency values, volumetric efficiency values, and electric motor efficiency values. This is the case if we have to use the isentropic efficiency values. But what if we want to use the compressor maps? For using the compressor maps, you have to click to this switch to maps button. When you will switch to maps, you will see here is a scroll down menu, and from here you can select any compressor maps which are already available in the library. In this example we will use R410A scroll 8.8 kilowatt compressor map. So I will just click on it. Now you have selected this compressor map. What other things you can do? First, we will just see what's inside in this map. So we will just go for edit selection and we will see what's inside it. So this is what inside in this map. You can see this compressor map is according to CAN, ANSI and AHRI standard 540. And you can switch the units from pound inch units to the SI units. So here you can see these are the values of the power input coefficient, and along with it you can see the values of refrigerant mass flow rate. In the bottom you can see the condenser subcooling value of 15 Kelvin, and you can see the refrigerant R410A. One important thing is that when you will select the compressor map of R410A, so it will switch the refrigerant selection to this refrigerant. For example, if at the start you are using another refrigerant, now you will move to the refrigerant and you can see like you cannot change the refrigerant. The compressor map option has been chosen. Therefore, the refrigerant is defined by the compressor map selection. Similarly, if you will select some other refrigerant, or for example you are going to select 9 ton with R290, that is propane, so here you will go to the refrigerant and you will see that the selection of the refrigerant has been automatically switched on. Another thing is that what we can see, we can also edit our selection. So edit means like when we will go to edit and we want to change this values, we can change these values. And what we can do is that we can see the modified temperature based coefficient values, pressure based coefficient values, and CAN, ANSI, AHRA standard values. So usually we use this CAN, ANSI, AHRA standard 540 values. So another thing what you can do is that if you want to create compressor maps which are not already available here for the refrigerants which are not here assigned, or for that you have to go for the create new, and it will open the window. Here if you suppose want to create your own compressor map, so you will name the file, maybe you want to create it for R134A, and here you will describe the compressor description, maybe its capacity, for example 10 kilowatt, or its type, for example scroll, or whatever it is. So what you have to do, you have to put the value of its superheating value, its condenser subcooling value, and you have to select the refrigerant name here. And then you have to put inside it the power input values and the refrigerant mass flow rate. So for the compressor map, like there are different datas available online. It will create your own compressor map data for that specific refrigerant or for that specific compressor. So what we can do, we can edit the already available maps inside this software. We can create our new maps, or we can delete the maps which are already present there. So another thing here we can see is the system cooling capacity. So for the system cooling capacity, we have two options. If we know the cooling capacity of our system, we will just input the cooling capacity of our system, which is here in that file is 11.8 kilowatt. Another option is about the capacity multiplier. So what does a capacity multiplier means, or what does it do? For example, in our example, we are going to select our 410A scroll compressor, and it has a capacity of 8.8 kilowatt. So if you want to use this compressor map with a duty of 8.8 kilowatt as it is with this capacity, you will use the capacity multiplier of 1. But for example, if your capacity is double of that this compressor, or if you are going to use two compressor parallel, you will increase this capacity multiplier with the value of 2. So in this way you can just change this capacity multiplier value according to your requirement. So in this example, first what we will do, we will just select the cooling capacity of 11.80, and we will select this R410A map. First we will run into the impose mode, and we will get the reference parameters. So this is what we will do. We will just run it or simulate it in the impose mode first, so that it will evaluate the heat exchanger parameters and our reference parameters, which will be used in our next simulations. So here you can see it has created the results of the impose mode, and now what we will do, we will going to run it into the simulate mode. Now we will run it into the simulate mode, and we will run this simulation again. So here we see the results. Here we can see that the compressor description, it says 8.8 kilowatt 2.5 ton scroll compressor, and the system cooling capacity is 11.80 kilowatt. And below is the thermodynamic cycle points, state points data, and below is the compressor and the system results. So here you can see the compressor power, you can see the COP of cooling and COP of heating, and the compressor suction volumetric flow rate value. Also you can see the isentropic efficiency value. When we was running in the isentropic efficiency mode, it was 100%, but now you can see the actual or the real value of the isentropic efficiency. So this is one of the advantage of running this simulation using the compressor maps, so you can get the real values or the real results. So here what we can see, we can also see the refrigerant mass flow rate values, total power consumption values, cooling capacity values, and the heating capacity values. So this system capacity multiplier value is 1.22, which means that the system is operating at 22% higher capacity than its rated capacity. And below here you can see the heat exchanger results values also, which gives you the refrigerant mass flux values, delta T values, overall heat transfer coefficient values, and other pressure drops and refrigerant size thermal resistance values. So now what we will do, so now we will run it with a capacity multiplier of 1, and we will see the results. So here we can see the results. Now you can see that the description is compressor description of 408.8 kilowatt 2.5 ton same, and the system capacity multiplier here is written instead of the system cooling capacity value. And now we can see again the state point values, and then the compressor and the system results. And here we can see the compressor power of 1.827, and the COP of cooling and heating value, and the volumetric flow rate values, and the isentropic efficiency of 0.672. So here we can see like how we can run this compressor maps in this simulation, and how we can utilize this real compressor map data for our system simulation to get some real results. So other things you can do is that you can change these compressor maps with these available maps. For example, for this 2.5 ton with R407C or 3.5 ton R454P and 9 ton with 9 R290, you can vary the cooling capacity values, or you can multiply these capacities with the capacity multiplier accordingly, and you can get the actual results of the simulations, which are quite reliable. So this is the advantage of using the selected compressor map. You can get the real values of isentropic efficiency of the systems, and you can get some real data out of it. So that is all about this video. If you like this video, please like my channel, subscribe my channel, and that is the only way for motivating me to make such more videos. Thank you very much.